Okay, so now I'm doing part 1, which is a stepper motor controller, and there are actually three inputs. The first one is enable stepping, which allows the outputs to change. The second input is a controller for the direction of the stepping, and then the third one is a clock. So this one is a stepping sequence for the motor controller, and this one is the step diagram for the more step machine, and all this are this one is a step table, and then finally this is a K-map, and here are the output functions for the respective outputs. And now let's look at the circuit. So this switch here is the enable stepping EN, and here is the control for the direction of the stepping, and this one is the motor emulator. So now when you without the enable stepping, even if I press the okay, so this one is the input for enable stepping, this one is CW, and then without the enable input, even if I press on the controller for the stepping, then nothing will happen. But once I press on the enable input, the motor starts to rotate. And then now, since input from the controller is 0, so it's actually rotating anti-clockwise. Once I turn it on, then it starts to rotate clockwise. And another input is the clock. So if I change the frequency of the clock, then it starts to rotate faster and faster. Yeah. And then now, once I stop the enable stepping, then it stops there, and then stop, and stop, and that's it. Hi, I'm Jonathan. So now let's look at part 2, linear feedback shift register. So now let us look at the state diagram. This is a state diagram, and then let's look at the timing diagram now. Let's focus on x0 only. So as you can see, for one clock cycle, it goes from 0, and then for the next it goes to 1, and then 0, and then 1, 1, 1, 0, 0. And then now let's look at our testing. So this one is a clock, and this one is the output from x0. So as you can see here, let's start from here. For one clock cycle here, for one clock cycle it's 1, and then for the next clock cycle it's 0, and then for the next clock cycle it's 1, and then next clock cycle again 1, and then 1, and then 0, and then 0, and then 1, back to 1. As we can see from here, it's actually 1, 0, 1, 1, 1, and 0, 0, and then here is supposed to be 1, which can be looked from x1. 1, 1, 1, 0, 0, 1. Pause. Okay, now for a 7-bit linear feedback shift register, we are constructing a length of 1 to 7 using this equation. So this was our previous schematic where 4 and 5 is connected to the XOR gate, but now to make it 7, we move from for X, previously the 1 from the XOR gate, we move it to X3, and then this one, the second one, will move it to x0 to fulfill this equation. So now let's proceed to the testing. As we can see here, the output, this one is a pause output, so you can see it's actually quite random. Pause it again, yeah, it's like there's no specific pattern for it. The output is actually random. So yes, the output is random.
Okay, so I'm Aaron and I'm doing the part 3 of this experiment. So part 3 is about to design a milli-stack machine to detect the sequence 011, and then we should implement the design using D-type flip-flops, and we use the input from part 2 to test the circuit. So as you can see, this is the stack diagram, this is the stack table, and this is the K-maps, and this is the circuit we can see here. And moving on to our testing now. So the first part is the input from the part 2 of this lab, and the bottom part is the sequence detector. So we can see the result here that is shown, and you can see the small
011.
Oh yeah, 011. Then the output is 1. 011
is 1.
1. Okay, it's the same. Okay, so as you can see, there is a small spike there, which is the false output for this lab.